There we go. Okay. What does a graph that has a proportional relationship look like?
Linear.
It's linear.
It goes through its origin.
And it goes through the point of origin, okay? I can use the constant of proportionality to compare the pace of different animals. You did that with the ladybug and the ant, didn't you? Okay, so we're gonna build on what you just did with the ladybug and the ant. So remember that the line U is the ladybug. So this is the ladybug. And line V is the ant. Okay. What would be the graph of a bug going 3 times faster than the ant look like? Well, let's come here and look at the ant. Let's pick a point that we know definitely with the ant. I'm going to pick this one right here. It's in the corner right here. So this is 3, 1. Okay, what does 3, 1 mean? 3 what?
3 is the constant of proportionality.
Nope.
3 centimeters in
3 centimeters in 1 second. The constant of proportionality is right here. It's 1/3. Okay? All right. Now, we want a bug that is going 3 times faster than the ant. So that means at 1 second, where will that new bug be? 3 times faster. The ant at 1 second is at 3 centimeters. So where would the new bug be if he's going 3 times faster? Three centimeters to go in 1 second. How far will the new bug go in 1 second if he's going 3 times faster? 9. He will be at 9 centimeters. So I'm going to do 9, 1. So 9 is right here, 1 is right here. I'm going to erase what I wrote here so I can do it. So they wanted me to graph it, so it's going to be down here. So this is 9, 1. So what is the COP for the new bug?
1/9.
1/9. So this would be 1, 1/9. So the equation for the new bug would be time equals 1/9 d. This one was time equals 1/3 d, and this one was t equals 1/2 d. Now yesterday I told you that generally if something was going faster, it was steeper. Why is this one, this is the fastest one here, the new bug is the fastest one. Why is his not the steepest one?
It's swapped.
It's swapped. I put distance down here this time and time on the side. So you have to be careful about what the x-axis means and what the y-axis means, okay? Which is why I picked a point and I said that means 3 centimeters in 1 second. Yes, that is 3, 1. But what does it mean in this story? And that helps me to understand what's going on. Okay? Questions you have about this? All right. There it is. Okay. Let's see. What would an equate? We just talked about the equation. We got ahead of ourselves there. So if we wanted to scale the graph so we could see how long it takes the ladybug to travel 50 centimeters, how far up would we have to go here? So what are they asking us to figure out?
How long it will take the ladybug to travel 50 centimeters?
Okay, do you remember her equation? What was her equation? Time
K equals
1/2 d. So if we know her distance is 50 centimeters, I'm going to plug that in right here. T equals 1/2 times 50. So what is her, how long is it going to take her to go 50 centimeters?
100 seconds?
What's half of 50 seconds?
I was 25.
25. It's going to take her 25 seconds to go. So we would have to extend this line all the way up to 25. Is there another thing that we could do? Could we make each line worth 5 and redraw the graph? We could do that as well. But we'd have to have 25 on the vertical axis. Okay, do you see where we got the 25 from? Okay. Questions you have for me? All right. We're getting there. We got one more to go before we do the practice problems. All right, we have a graph here that represents the position of 2 turtles in a race. On the same axes, draw a line for a third turtle that is going half as fast as turtle G.
Is this the practice problem?
No. Okay, we want to go half as fast as turtle G. So we need to figure out how fast is turtle G going. Well, where the COP is, it's kind of hard to tell. It looks like he's around 1/2, but we don't know exactly. So what I'm going to do is I'm going to pick a point where turtle G is in the corner here. So turtle G is right here, and this point is 2, 1. Now what does that 2, 1 mean? 2 what?
2 is the coordinates for the graph.
Okay, and what does the 2 represent? 2 centimeters in 1 second. Do we agree? Is that what 2, 1 means for turtle G? He went 2 centimeters in 1 second.
Yeah.
Okay, we want a third turtle that is going half as fast. So in 1 second, where will the new turtle be? Bella's holding up her finger. She said it will be at 1 centimeter. Give me a thumbs up if you agree. Good, because half of 2 is 1. So that means the third turtle is going to be at 1, 1, which is, let's do a different color. 1, 1 is right here. Then it will be if, so.
Is this one on our notes?
No, this is a different problem. Okay? So we have x is 1, y is 1. What if x is 2? What's y going to be? 2.
No.
Right? Because what's the COP here?
1.
1, So then the third turtle is going to look like this. Okay? Do you see how I figured that out?
Yes.
Who can explain to me how I figured it out? What did I do first?
Divide 2 centimeters in half.
Okay, where did I get this 2 centimeters in 1 second?
You divided that by 2.
Where did I get 2 centimeters in 1 second though? Where did that number come from?
Turtle G.
Turtle G. That's this point right here. And then I divided it by 2 because he was going half as fast. And that gave me one of the points. And could I have just done 0, 0, and 1 and just kept going? Yes, because we were told it was a constant speed. Okay, questions you have on how to do that? All right, let's do the practice problems. The practice problems, there's only 2 of them. You're going to submit the graphs. Okay, so you will do this, you can do this on the PDF and then screenshot it and submit it. All right, so Priya jogs at a constant speed. The relationship between her distance and time is shown on the graph. So in this one we have distance over here and time down here. Diego's bike's at a constant speed twice as fast as Priya. Okay, so Diego's going faster. Is it going to be above Priya or below Priya?
Below.
We now have distance over here and we have time down here. It's going to be above this time, okay? All right, so I just wanted you to visualize that. So we want to go twice as fast. Well, do we know exactly how fast Priya's going? Did they tell us up here? No. Did they tell us in the graph? Can we figure out how fast she's going? How would we do that? What do we need to do? Pick a point. All right, what point do we want to pick? Let's pick this point right here.
Number 4.
Okay, what does this point is 0.4, comma 2. What does that mean? What does the 0.4 mean?
Point 4 point
Hours.
4 hours.
What does the 2 mean?
2 miles.
2 miles. So Priya jogged 2 miles in 4/10 of an hour. Diego is going twice as fast. So in 4/10 of an hour, where would he be if he's going twice as fast? 4 miles. We just multiplied it by 2. Okay? At 0, would he be 0 miles? At 0 time, would he be 0 miles? Yes. Okay. Then we have the point 0.44 right here. So now can we draw a line? There is Diego. Because this is 0.44, which makes him twice as fast. And if you look down here, is he twice as fast here at 0.1? Mm-hmm. Is he twice as fast here? Yes. Okay. Questions you have for me? Okay, who needs more time? All right, let's do the second one and then we'll be finished. A U-Pick Blueberry Farm offers 6 pounds of blueberries for $16.50. Sketch a graph of the relationship between the cost and pounds of blueberries. So it looks like they want us to put cost over here and pounds of blueberries down here. So how do we know what we're graphing? Where are we going to get a ordered pair from, an X comma Y? where are we gonna get that x comma y that we need to graph? Because we know 0 pounds of blueberries is gonna cost us $0. So we know that. So how are we gonna get an x and a y to graph so we can draw a line?
By plotting the 6 and the 16 point.
Okay, so the 6 and the 1615. Now we have to decide, is the 6 the x or is the 1650 the x? Well, come down here. What is the x-axis representing? The pounds, okay? So, is this our x? And this our y?
Yes.
Okay, so we're gonna plot 6 comma 16.5. So I'm gonna find 6, so that's fine. Here's 6, just a little bit past it. 16.5 is probably gonna be somewhere in here. And then I'm just going to draw that like that. Okay, questions you have for me? Could we figure out the COP? How much does 1 pound of blueberries cost? What are we gonna do to figure that out?
Whatever. Times 16.5.
Okay, so 16.5 divided by 6, I think is 2.75. Is that right? Can't find my calculator. Do y'all have a calculator?
6 times 5 equals 38.
No, we're taking 16.5 divided by 6.
16.5 divided by 6.
Yep, I was right. Alright, so somewhere in here, it's kind of hard to tell. What would 10 pounds cost? If 1 pound costs $2.75, what do 10 pounds cost?
$27.50.
Very good. Alright, are we close? Yeah, we probably are pretty close on our graph. Okay? How do you feel about that one? Do you understand how I determined what was x and what was y?
Yes.
Okay, and I was told it was proportional, so therefore I knew it had to go through 0, 0. All right, that takes care of the practice problems. And you have a great weekend. I'll see you on Monday. Some of you I will see in person.